All right. We're starting out with Pythagorean theorem. Pythagorean theorem you guys have had before. A squared plus B squared equals C squared. A squared plus B squared equals C squared. This only works on right triangles. And a right triangle means it has a right angle in it. All right? Right angle meaning 90 degrees. Pythagorean theorem will only work for those triangles. Now, always in the triangle, always, opposite your 90 degrees is your hypotenuse. Always, Damien, always. And that will always be, in this equation, it'll always be your C, okay? That's something you need to remember. That always happens. Hyper C? Okay. It doesn't matter over here which one of your legs is A and which one's B. It can be either or. It doesn't matter. But this is always C, your hypotenuse. Something you have to remember. Do I have to say that again? Something you have to remember. Now, we can find that if we're given two sides, we can always find the third side. So if I'm given a triangle, let's say, of 2 and 4, what am I missing? C. I'm missing my hypotenuse length here, my C. I can call this A or B, it doesn't matter. Let's just say it's 2 squared plus 4 squared equals C squared. 2 squared is 4, plus 4 squared is 16 equals C squared. 20 equals C squared. And then we take the square root of it. Is it a plus or minus when we do the square root? Always plus. Because we can't have a negative side, right? All right, not unless it's a C, which goes with Cade, and then it can be negative. Just kidding. Just kidding. All right. So we're going to have 20 equals C squared. We're going to do the square root of both sides. This square root gets rid of the square root of 20. Now, do you need to reduce this square root? Technically, yes. Technically, yes. Am I going to require it? No. Technically, yes. But not now, okay? We can just leave it as square root of 20. That will tell me enough that you know how to do it. All right? Yeah, I know you guys do. You punch it in a calculator when you can just leave it as square root of 20. Just leave it as square root of 20. You don't have to punch that in. Yeah. So on the first side of this, it is going to ask you to find the missing side. So this one here, we know we're missing our hypotenuse, missing a hypotenuse. This one here, our hypotenuse is given, so we have to look for A or B, one of the two. Here the hypotenuse is given, and we have to look for, let's say, an A. Okay, let me give you an example. I've got a right triangle, and let's say this is square root of 10. This is 2, and this is 3. Will that work out? I'm going to make this bigger. I don't know if that'll work. Let's make this a square root of 20. Okay? I don't want to make that 3. I want to make this B. Now we're good. We're looking for this one side. So I'm going to go 2 squared plus B squared equals square root of 20 squared, right? Square root of 20 squared. So I end up with 4 plus b squared equals 20. Take the square of a square root, they eliminate each other. They get rid of each other. So I'm just left with what's ever in here, 20. I subtract 4 from both sides. B squared equals 16. What do I square to get 16? 4. B equals 4. See how I did that? That's what you have to do for this first side. You're going to have to find the missing sides to this. So here, this would be a 10 squared. Okay, this would be a 6 squared. It'd be 6 squared plus, let's say, b squared equals 10 squared. Down 5, 6, and 7. A square has a side of length of 9. What is the length of the longest segment that can be drawn between any 2 points of the square? A square has a side length of 9. Okay? So it's a square. It has 4 equal sides, right? 9, 9, 9, 9. No, I'm not German. I'm going to draw a diagonal between them. I've got a 9 for A, a 9 for B. What is my C? That's what it's asking for. Okay? That's what you have to find out. A right triangle, ABC, has legs of 4 and 7. What is the length of the triangle's hypotenuse? Well, here they have 4 and 8. All you have to do is make it 4 and 7. Televisions are sold by the length of the diagonal across. Did you know that? When they say it's a 36-inch screen, they measure the diagonals. That's how they do a TV. Yeah, and its diagonal is 50. So I have a television here with a diagonal of the screen of 48 inches. The television screen is 42 inches wide. All right? It's 48 across, so it's a 48-inch TV. But when we measure across the bottom here, like you were talking about, Kate, it's 42. What's the height of it then? So we have a TV like this. Across here is 48 inches. Across here is 42. What's this one right here? That's what you have to figure out for number 7. All right. Now the second side of this page, we're going to work with obtuse, acute, and a right. How do we know it's obtuse? Greater than 90. We have an angle on it that's greater than 90. What's an acute? Less than 90. Me, acute. Less than 90. Me, acute. Okay? So obtuse is greater than 90. Acute is less than 90. And a right equals 90. Okay. If we're using the Pythagorean theorem, and we want to figure out if it's an acute or an obtuse, here's what we do. Obviously, if we take 3 numbers, let's say 6, 8, and 10, okay, and we put those into the Pythagorean theorem, 6 squared plus 8 squared equals 10 squared. We figure this is 36 plus 64 equals 100. Is that true? Yep. It's true. So we know that this right here, because this is true, because these do equal, this is 100 and 100, we know that this is a right triangle. All right? If we take three numbers and we square them out and they come out equal to each other, we know it's a right triangle. If we take three numbers, 3, 5, let's go 10, and we put those in, so 3 squared is 9, plus 5 squared is 25, and 10 squared is 100. What we end up here is 34 is less than 100. What kind of triangle is it then? An obtuse triangle. If this side, a squared plus b squared, is less than c squared, it's an obtuse triangle. If this happens to come out greater than this side is greater than this side, then it's an acute triangle. All right? If it's equal, then it's a right triangle. Questions with that? You have 2 through 16. Don't worry about 17 and 18. So do the first page, and then do these 9 on the back page.